everyone, welcome now to question 4. And question 4 says the production function Q equal K to the power of A, L to the power of B is called a Cobb-Douglas function, where A is any value between 0 and 1 and B is any value between 0 and 1. This function is widely used in economics research. Using this function, show the following. Part A. The production function in equation 4 is a special case of the Cobb-Douglas function. Now equation 4 is this equation in section 7.4 in the textbook. So equation 4 from the textbook says that Q is equal to K to the power of 0.5, L to the power of 0.5. And this is obviously a special case of this, where A is equal to B, which is equal to a half. Alright, so that answers part A. Part B says, if A plus B is equal to 1, a doubling of K and L will double Q. So we need to show that, but before we show that, let's remind ourselves what is return to scale. So there are three types of returns to scale. So you can pause this, read all about it, make sure you understand this fully, and then we move on to answering part B. We need to show that if A plus B is equal to 1, a doubling of K and L will double Q. Let A equal 0.5 and B is equal to 0.5. Therefore, A plus B is equal to 1. Q is equal to K to the power of 0.5, L to the power of 0.5. And now if we double the input factors K and L, then we'll have a new production function. Let's call it QA. QA is equal to 2K to the power of 0.5 times 2L to the power of 0.5. So we basically doubled our input factors. K is doubled, L is doubled. And let's see how much output would we now get. So this is equal to 2 to the 0.5 times 2 to 0.5 times K 0.5 times L 0.5. This should equal to 2 K to the 0.5 L to the 0.5, which is basically equal, well, this is essentially our original production function. So QA is equal to 2 times the original production function. So by doubling our input factors, we exactly doubled Q. Therefore, this shows constant return to scale, right? Constant returns to scale. Now let's check out part C. Part C says, if A plus B is less than 1, a doubling of K and L will less than double Q. Now we need A plus B to be less than 1. So let A equal 0.4 and let B equal 0.5. Therefore, A plus B is equal to 0.9. So our original production function would have been Q is equal to K to the power of 0.4, L to the power of 0.5. This is K to the power of A, because A is now 0.4, L to the power of B, because B is now 0.5. Right? And now let's double our input factors, K and L. Right, so since previously in part B we used QA, now we would use QB just to differentiate our production functions. So QB is equal to 2K to the power of 0.4 times 2L to the power of 0.5. So this is equal to 2 to the power of 0.4 times 2 to the power of 0.5 times K to the power 0.4 times L to the power 0.5. So this is equal to 2 to the power 0.9 times, well, this here is essentially our original production function, which we had here. So this is equal to the power 0.9 times Q. So this is actually equal to 1.87 Q. So our QB, our output, is equal to 1.87 Q, which is less than 2Q. So it's less than double our value for Q. Alright, so this is how we show that if A plus B is less than 1, a doubling of K and L will less than double Q. Now let's check our last mathematical part. If A plus B is greater than 1, a doubling of K and L will more than double Q. So in this case here, since we less than double Q previously, this would have been decreasing returns to scale, right? Now, in this question, I'm expecting to see increase in returns to scale because we double in K and L, so we double in the input factors, but we want more than double of output. So it'll be increase in returns to scale. This time we will let A equal 0.6 and B equal 0.5. Therefore, A plus B is equal to 1.1, which is greater than 1, right? Production function would be K to the power of 0.6, L to the power of 0.4. So let's create a new production function. Let's call it QC and say QC. So we're going to now double our input factors. QC is equal to 2K to the power of 0.6 times 2L to the power of 0.4. So this is equal to 2 to the power of 0.6 times 2 to the power of 0.4 times K to the power of 0.6 times L to the power of 0.4. So you notice this here is our original production function from here. So this is just equal to Q. So we have 2 to the power of 1.1 Q, QC. And if you calculate what is the value of Q to the power of 1.1, we get 2.14. So QC is equal to 2.14 Q, which is more than 2Q. So by doubling our input factors, we more than doubled our output, right? So this represents increasing returns to scale. And that answers all the mathematical parts. And the last part of this question says, using the result from part B through D, what can you say about the returns to scale exhibited by the Cobb-Douglas function? Well, we could say that the function can exhibit any returns to scale desired depending on the value of A and B, as we saw between part A to part D. If A plus B is equal to 1, then the Cobb-Douglas function will give you a constant return to scale. If A plus B is less than 1, then it is a decrease in return to scale. And if A plus B is greater than 1, then you would get increase in returns to scale. And that's it for this question. And thank you for watching, and I'll see you in the next one. Goodbye.